What teacher speaks Russian?
Huh?
Hello, girl.
Yeah, she teaches. What does she teach? Economics or what?
Economics.
Microeconomics.
Yeah. More power to her. Okay, so the first section. Now, does anybody have any questions about the My Labs Plus? Any questions on how I do things? Any questions on anything? I sent out another set of handouts from someone by yesterday. Does anybody have any questions? Okay, well that's good. Nobody has any questions. So I covered the material so well that y'all don't have any questions. All right, the first section. Now, I'm going to teach this 109 as an algebra course, and then we're going to put in the modeling with the algebra. Now, what is modeling? Modeling is a 25-cent word for word problems. Okay? So we're going to do the algebra first, and then hopefully you'll be able to work around the word problems. I don't know how much algebra you've had. I'm not going to go through and ask if you've had algebra 1 and algebra 2. This is like an algebra 1.5. Okay, because they had to water it down. I'm sorry, they had to make another class so people could pass it in the business areas. So they had to water down. I'm sorry, they did. They had to water down Math 110, and that's what we got. We got Math 109. So, and they said that they took the 110 and put more business modeling in it. Well, I disagree with that. I think they kind of took all the hard algebra out of it, is what they did. But I'm just a teacher. That's all I am. Anyway, I want to try to go with teaching the basic algebra. I mean, the algebra in each section, and then branching off and trying to do the problems after we cover the basic algebra. So we're talking about algebra 1 to 2, somewhere in there. So that's how I'm going to do it. I hope that'll work for y'all. Has anybody got any questions that they've ever had about algebra? I always like to ask that question. In other words, of all the algebra you've taken, if you ever have a question that you just wanted to ask but was scared to ask it, or just didn't want to ask it because of whatever, any questions about algebra? Any? Okay, you're not going to ask anyway. Y'all just going to sit there and be quiet now. I've started class, so you're not going to talk to me. All right. The first thing, functions, domain, and range. This is not a... Hold on. I got to get back over to this. There we go. There we go. Oops. All right. As you can tell, I've got several pictures up there. One is an ice machine. The second is a hay baler. The third is a bicycle. These are all functions in real life. In a ice machine, that's the ice machine that they used to have in the on each floor of the hotel. They don't have those anymore. They got those that just put out like a cup at a time, so you don't steal all the ice or have ice fights on in the hallway. Anyway, that's what they used to look like. And if you put water into that ice machine, you're going to get ice. Well, let's say that you hook up a funnel and a hose into that ice machine, and you pour in 5 gallons of cherry Kool-Aid. What will you get out of it?
Kool-Aid ice.
You would get 5 gallons worth of Kool-Aid ice. Let's say you poured 2 gallons of lime Kool-Aid. Whoever in the world likes lime Kool-Aid. But anyway, let's say that you put in lime Kool-Aid, but you only put in 2 gallons. What would you get out of it? 2 gallons of lime Kool-Aid, Hubert. Ice. That's right, class. Thank you for the interaction. What if I put in 10 gallons of grape Kool-Aid?
You get 10 gallons of
I
grape Kool-Aid
get
ice.
10 gallons of grape Kool-Aid ice. So can you agree that the ice machine, what you put into it, that's what you get out of it? Yes, or no? Yes.
Yes.
Yeah.
Okay. Same thing with the hay baler. If I put in, so much grass, which is called, after you cut the grass down and it cures, it's called hay. If I cut that grass down and I put it in the hay baler, I'm going to get a hay bale out of it. If I put double the amount, then I'm going to get 2 hay bales, and so forth. So again, what I put into the hay baler, I get out of the hay baler. Same thing with a bicycle. If you try to ride a bicycle and you don't have any legs, what's going to happen?
You're going to fall over.
You're going to fall over. Now, I've been saying that, I'm offended. I'm offended. Okay, well, what happens if you don't have any legs and you try to sit on a bicycle? You're going to fall down. I mean, there's nothing offensive about it. That's just physics. Okay? It's just like if you try to catch a baseball and you don't have 2 arms, you're going to get hit with the baseball. I mean, it's just physics. I'm sorry, but that's just physics. That's just the way it is. Now, if you don't have any legs and you fix that bicycle to where you can use your hands like they have fixed, or a wheelchair type bicycle, then yes, you can move. But the point I'm trying to tell you is, if you don't have some way of putting energy into that bicycle, it's just going to sit still. Okay? Now, all of these things are what you call functions. And the function in algebra is the actual equation. What you put into the equation is x. What you get out of the equation is y. Now, let's go back to the ice machine. If I put in 5 gallons of cherry Kool-Aid, I'm going to get out 5 gallons of ice, worth of ice. So what I put into it, I'm going to get out of it. What determines what? Does the domain determine the range, or does the range determine the domain?
The domain determines the range.
The water, the Kool-Aid, determines how much ice you have. Okay? The grass determines how much hay you have. How much power you put into the bicycle through your legs depends on how much movement you get out of the bicycle. So the X determines the Y. That's what you need to get out of this. Now, right now, I've probably got, let's say there's 18 students in here. I've probably got 6 students that says, I invented domain and range. And then I got 6 students that says, that's a little bit clearer. And then I got 6 students that says, I've never seen this before, but I understand it. Okay? So I don't know who I've got where, but just keep your mouth shut, especially if you invented domain and range back about, the 1st century BC. Okay? But that's the introduction I give to domain and range. Next slide. How do we write domain and range? We write domain and range using the symbols with parentheses and brackets. And that is the 2 symbols, the inequalities on the left that you see right here. Let me get out my handy dandy. Let's see if I can do this. Hold on just a second. I forgot to do this. Okay, I do have it. There it is. Okay. Sorry about that. Let me go back to where I was. Well, I lost my mouse. There. Now, does that disappear when I do the slideshow? Or is that it? What is that? Huh. I guess that's it. Let's see if I can use these 2 guys. I don't know where this marker's coming from. It's not from the whiteboard that I usually use. Must be from the PowerPoint. Those two guys right here are represented by open circle, and this is not, just bear with me a second. I've never seen this before. Okay. I wonder if I didn't do this. Yeah. Does better without the... Okay. Closed circles represent these two guys. Why does the closed circles represent those two inequalities?
It's equal to.
It's equal
So it could
to.
be
In other
that
words, you can use the number. Same thing with the brackets. Okay, so when you're writing domain and range, you have to remember these symbols and these things that go with those symbols. The open circle goes with these, and the parentheses go with these. Now, this is a review for most of you, and I understand that. Some of you may haven't had algebra in a long time, so just bear with me. So, if I give you a function, and I tell you, and I don't want to write it because I can't get I'm not used to this right here, so I'm not going to fool with it, and plus I don't think they have straight lines, so we're just going to go to the next one. But set builder notation would be braces x such that x is greater than or equal to, that's supposed to be greater than or equal to 4. It's hard to write with a mouse. Okay? Interval notation would be parentheses, and this says x greater than or equal to 4. That would be, I'm sorry, that's equal to, so that'd be bracket. Bracket 4, comma, infinity. Okay, so if I had a domain of x is greater than or equal to 4, then I could write it in set builder notation, or I could write it in interval notation. Now, most of you are probably saying, oh yeah, I remember that. We did that back in blah, 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 blah. Okay? And some of you may be saying, okay, I remember a little bit, but I'm still not remembering all I need to. Just bear with me. We're going to go over a few examples here, and hopefully you'll catch up. Okay? So, next slide. Let's say that we give you a f of x is equal to 2x plus 4. And I tell you that I want you to plug in numbers from -2 to 2. Now, I tell you, or the directions on the test or the homework tell you, to use -2 to 2. What am I setting up when I tell you -2 to 2? What am I setting up?
The domain.
Thank you. So write that down. I'm setting up the domain. No, forget it. I can't do this. This mouse just don't work right. There. -2 to 2 is the domain. And I set that up as the teacher, or the homework, or the test directions set that up. If it's not set up by those three entities, then it's just all real numbers. You can use any number you want to, unless the function doesn't let you. And that is in case of a fraction or a radical. So, I plug in -2 to 2, and that gives me those green numbers right there. And those green numbers, that's our ice. That's our Kool-Aid ice. The yellow is our Kool-Aid. The green is our Kool-Aid ice. So our range is from 0 to what? 8. But you don't know the range until you plug the domain into the function. And if you graph it, you see what the domain and range is also. Over here on the right-hand side, you've got, I've tried to line it up best way possible, but sometimes the graph and the graphics just don't cooperate. But anyway, you see that our yellow is on the x-axis from -2 to 2. And our green is from 0 to 6. It's supposed to stop at 6. Like I said, it wasn't being very cooperative. So, not only can you find the domain and range algebraically, you can find it graphically. Capiche? What
Yes.
problem, gripe, complaint? And here's another example. This is a quadratic. Quadratic is when you have a squared function. And of course, go ahead and I want you to, there's your numbers there, but I want you to kind of review over the graphing procedure. Go ahead and plot those points. Just make yourself if you got some graphing paper, that's great. If you don't, just make yourself a makeshift X and Y axis and graph those numbers just to kind of knock the cobwebs loose off of your graphing skills. Now, what numbers can we use for X? We can use any number we want to. Why? Because it's not a fraction or a radical. Can I plug in 0? Yes. Can I plug in -2? Yes. Can I plug in -1/4? Yes. You can plug in any number you want to. So the domain of this function is all real numbers. The domain of most of your functions will be all real numbers, except when the directions or the teacher prohibits it, or the function prohibits it in terms of a radical or a fraction. Any other than that, it's going to be all real numbers. Do we get any errors for Y if we plug in any numbers for X? No. Because you can have negatives, you can have positives, you can have 0. There's no error. Now, if I gave you the square root of X minus 2, then that would be a problem. Because I can't put in -3. Why? If I plug in -3 plus 2, what I get?
-1.
And what's the square root of -1?
1.
1.
Nope. Can't take the square root of what?
A negative.
A negative. So boom, you got a problem there.
2.
Your bicycle has no chain. Okay? You can put numbers in it all day long, but it's not going to what? It's not going to work. Okay? Or you just put Everclear in the ice machine. It ain't going to work. All right? You can try it, but it ain't going to work. So the domain is not restricted if you can use any numbers. And if the domain is not restricted, what about the range? It's not restricted. Okay? Versus this guy. The only numbers you can put in this one is 2 and beyond. Why?
Because you can't have a square root of 0.
You can't have a square root of a negative. So can we use any number for X? No. You have to use 2 and above. So the domain of this function is 2 and above, or X such that X is greater than or equal to 2.
So if you do the interval thing, would you put the bracket and then 2, comma, and then infinity?
Yep, that's
How you
right.
write that? Okay.
Okay. I would be writing on this thing right now, but I guess I could do this. No, it's not going to let me. Could do it right here. Let's see if this will work. So since, wait, that's not the right one.
Brackets.
Yeah, so it has to be a hard bracket, the first one.
Okay.
These. There. So, since we can put a 2, no, it's just not going to work. Yeah, something's up. It didn't give me this problem last semester. I don't know what's up. I'll have to check it. You can put 2 minus 2, but it would be bracket 2, comma, infinity, close parenthesis. That would be it. So the domain is restricted on this one. So if the domain is restricted, what can you tell me about the range?
It's also restricted?
It's also restricted. And you would have to look on the graph to see what it is. And you could take your graphing calculator, x minus 2, that means a horizontal shift of plus 2, which means it looks something like this. Okay? So you could say that your range is from 0 to what? Infinity. Your domain is from 2 to what? Infinity. Okay? See, I can draw with my mouse, so that tells me that something's up with this touch screen. Next question. I'm just going to go back to the slide. See, that's why it's so detrimental for the polycoms to have a board, because they're trying to put a square peg through a round hole, not having an Epson board and projection system. Okay, ask your question this. Is there any number I can put into this function? No. I cannot put in what?
4.
-2.
-2. Because if I put in -2, the chain's going to come off of the bicycle. Okay? If I plug in -2, that unplugs the ice machine. All right? -2 is a problem. So therefore, the domain is affected. If the domain is affected, then the range is affected. All right? So there is and notice, the first one we did, there wasn't the x squared plus 2x plus whatever. There's no restrictions. But as soon as I put a radical in the equation, and as soon as I put in a fraction, it was affected. Radicals and fractions affect the domain and the range. Write that down and highlight it so you can remember it. Okay? Since pre-algebra and algebra 1s, students have learned how to combine, multiply, and divide terms. Y'all have all done this. Okay? Students learn how to combine like terms. You got x plus 4 plus x minus 3. X plus 4 minus 3 is 2x plus 1. Now kind of follow along with me here because, like I say, I don't know what y'all remember. I don't know how long you've been out of algebra, so I'm going kind of along with the person that that's been out of algebra for a while. X plus 5 minus x minus 4. X minus x plus 5 plus 4. And you get 9. Okay? So you've done this before. Multiplying in pre-algebra. X, this is when you use the distributive, what in the world? Distributive law or the FOIL method. X times x is x squared. X times 3 is 3x. X times 2 is 2x. 2 times 3 is 6. Your final answer is x squared plus 5x plus 6. You just multiplied x plus 2 times x plus 3. Dividing. X squared plus 2x divided by x. Well, x squared divided by x is x. 2x divided by x is 2. Substitution. Y'all remember doing substitution? When y is equal to 2x and x plus y is equal to 4? What do you do with that y is equal to 2x?
You plug it in.
Plug it in. Plug and chug. So in pre-algebra and algebra 1, you learned how to do all these 4 or 5 functions. 5 functions. Addition, subtraction, multiplication, division, and substitution. Does everybody agree with that? I agree with that because I remember doing it. Now, you're going to do the same thing, except you're going to hold your pinky up because it's not sophisticated to do it that way anymore. You got to do it more sophisticated. Okay? In algebra courses, when you're talking about a function, you have to write it f of x. You have to, it's not y anymore, it's f of x. So you have to remember to do that. And then you got to remember to plug it in wherever there's a y. So y is equal to 2x, that's redneck. Now you got to be more sophisticated. Same thing here. So f of x is a fancy way of writing what?
Y.
How many times have you heard that?
Oh, good
A
bit.
good bit, probably. And you're not supposed to say that because some mathematicians will go into cardioinfarction if you say that, but it's the truth. And you can't write things the way you used to write them. You have to write f plus g of x, f minus g of x, f times g of x, f divided by g of x, and f composed of g of x. And all you're doing is the same stuff that you did in pre-algebra. F plus g of x. Here you go. Same thing. F minus g of x. Same thing. F times g of x. Or f plus g of x. Here's. Okay, this is where we're showing you. This is what you did in pre-algebra. This is what you did now. Okay? So, do not let, the whole purpose of me showing you this slide is do not let the functions confuse you because it will. I used to know a teacher that I used to teach the comprehensive studies algebra, the 101 and the 102. And I would teach them all this and they'd go into their college algebra and they would make an F because they have no idea what the teacher is talking about. Because they were talking this function and this function and this function. And we hadn't taught functions, until later on we decided to put functions into 102. But at that time we were not putting functions in 102. And teachers were blowing them out of the water because they were talking all this fancy function stuff. But they knew how to do the material, but they just were intimidated by the word function. So, anyway, don't let that happen. You know how to do this material. You did it back in the 9th grade and the 10th grade. All you got to do is just remember how to do it because you're doing the same thing. Remember doing the multiplication with the distributive law? Same thing. There's no difference in when you did it in pre-algebra and now you're doing it in functions. There's no difference. And you'd be surprised at how many people don't know that they're actually doing the same thing. Division. X squared plus 2x divided by x. It's x plus 2. But now you have to hold your pinky up. You have to say f of x is equal to x squared plus 2x. G of x is equal to x. Now find f divided by g of x. And that's what you're doing. This did not change any way from what you did back in pre-algebra. Plugging and chugging, same thing. Y is equal to 2x plus 3. 2x plus 3y is equal to 14. Take the 2x plus 3, plug it in. Same thing. Here, it's going to look like this. With functions, you see f of g, fog. Now, you might want to make a note here. When you have f composed of g, that means you're going to rewrite f with big sets of parentheses. So, when I have f composed of g, I'm going to rewrite this guy right here. And wherever there's an x, I'm going to put in a big set of parentheses. And that's what I did with the blue here. See the blue? Now, what is g? X plus 7. So I'm going to take that x plus 7, and it's going to go in that blue set of parentheses. Now, this is a very important slide, because if all the five operations that we do with functions, the composition is the one that y'all mess up the most. Not y'all in here or at Pendleton or at Easley. I'm talking about students in general, because they get confused. Now, g of f. G I'm going to rewrite with a big set of parentheses. So I'm going to put a big set of parentheses right here. And there they are, the blue parentheses. And then what am I going to plug in there? F. And I'm going to solve. Now here's one that gets people on tests, especially on a standardized test. F of f and g of g. Basically, you're going to plug the operation, the function, into itself. And that's what you get. Whichever letter is first, you rewrite the function with a big set of parentheses for x. Then plug in the other function. So this slide is a nice slide to keep, in your notebook, or at least the concept of composition you need to keep somewhere in your notebook, because this is the one you're going to forget, or the one you're going to mess up on. Okay? And that's functions. Now, next part of your section is chapter 2. That's all. I just went over all 4 sections in number 1, as far as the algebra that covers that section. Not the modeling, but just the algebra. All right, now I'm going to look at, I know I've only got a few minutes, and I'm just going to go ahead and start showing you what you need to look at for next time.
I don't think
Graphing.
It's already posted.
What?
None of that due dates. Are you going to post due dates on the homework?
When we get close to the due date time, yes. Okay? In other words, what's the last section that we cover in the outline?
I don't know.
I don't either.
All right.
You know why I don't know? Because I don't need to know. Y'all the ones that need to know.
It's right here.
I'm waiting for somebody that has the outline. Everybody should be pulling out their outline right now.
September 11th. It's around September 11th.
No. What section is the last section?
For this unit?
For the unit. Unit 1.
2.4.
Okay, when we get to 2.3, that's when y'all need to start worrying about dates. And then I will go through the test in class, and I'll post the dates on the homework, and I'll post the dates on the test. That's the way I do it. Okay? All right, so graphing. I'm just going to go through this right quick. This is what we'll do Tuesday or whatever time y'all come back, Monday or whatever. Graphing rules and properties. I'm just going to go through it right quick. And you don't have to write anything. Just look at it. Okay? And number lines, you had the number line. We graphed on it. Now we had the X and the Y axis. First, second quadrant, third quadrant, fourth quadrant. And talking about slope and y-intercept. Talking about plugging and chugging to calculate the slope. Point slope equation. Vertical and horizontal lines. Comparing the slopes. Methods of graphing. Method 1, chart plot. Method 2, intercept method. Method 3, building a line. And that's all that is. Okay? So, what I want everybody to do this weekend is try to get as much done on chapter 1 as possible. There's 4 sections. If you can't do it, don't worry about it. Send me the question. Okay? Ask my instructor, send it to me. And then we will spend Wednesday or Monday next week going over questions and incorporating the algebra that I've covered with the modeling that's in the book. Okay? Now, let me call the roll right quick. I hate these 1 hour classes. Feels like I just started class a few minutes ago. Where's my Skype? It's Russian's fault.
That's it.
Just think, if it wasn't for them Russians, we've had Hillary for president. Wouldn't that be so much nicer? Stop recording. Y'all know I'm being sarcastic. I hope.